Okay, Algebra 2, 9.1, we're doing right triangle trigonometry. Okay, our objective for this lesson, be able to evaluate the trigonometric functions of acute angles, find unknown side lengths and angle measures of right triangles, and use the trig functions to solve problems. Okay. So the 6 trigonometric functions. In geometry, last year you were introduced to 3, sine, cosine, and tangent. If you remember from trig last year, we had an acronym that we used. So, TOA. And we use this to help us solve right triangles. So these only work if our triangle has a right angle. Okay, so we need to start first by looking at our right triangle and talking about the sides and the angles of this right triangle. First of all, if you have a right triangle, let's go ahead and let's label this right triangle A, B, and C. The labels are on there, so let's go ahead and add them. So let's put A up here, B, and C. So if you notice, C here is where our right angle is located. Okay. The side opposite C, this side opposite C, that one right there, if you remember from geometry, is what we call the hypotenuse. The hypotenuse is always opposite this 90-degree angle. So it's always the side opposite the 90-degree angle, and it's always the longest side. The other two sides we refer to as legs. So a right triangle has a hypotenuse and 2 legs. Okay. In any triangle, in any right triangle that has the same acute angles, we know that they're all similar, which means the ratio of their sides is all the same. So we can actually talk about the angles in terms of their opposite sides. So we need to, if you remember from geometry, okay, if we focus on one angle here, let's focus on angle B. So we're going to focus here on angle B. Okay, if this is my angle B, if my angle B is right here, then the side opposite angle B would be this leg over here, A to C. So this one would be opposite angle B. And since this leg right here is right next to it, it creates angle B. This one we call the adjacent side to angle B. Now the opposite and the adjacent aren't always set in stone, because if I was looking at angle A instead, my opposite to angle A would now be this side over here. And my adjacent to angle A would be over here. So what our 3 trig functions do is they relate the angle to the ratio of the sides. Okay. So a little bit of, okay. So they relate the ratio to the sides, okay, to the ratio of the opposite sides. Okay, so, and if you remember from geometry, we tended to use Greek letters for our angles. So let's say this angle there is theta. This angle, this symbol here is the Greek letter theta. Okay, and we use that a lot for our angles. So if that's my theta, if you remember, sine was SOH. SOH, it stands for sine opposite hypotenuse. So sine of theta would be equal to the opposite side, the ratio of the opposite side to the hypotenuse. Okay. Cosine was C-A-H, so cosine is adjacent over hypotenuse. And the tangent of angle theta, then OA is TOA, so that would be opposite over adjacent. Okay. Again, a reminder from geometry that this is not a multiply. This here does not mean sine times theta. This is the sine of theta. So the sine of that angle is equal to the ratio of the opposite to the hypotenuse. Okay, so those were the three trig functions that we had learned before. Okay, so now we're going to learn three new ones, but these really aren't too horribly new. Cosecant is actually the reciprocal of sine, so it's equal to 1 over the sine of theta, which, since sine of theta is opposite over hypotenuse, cosecant would be equal to hypotenuse over opposite, the reciprocal. Okay, so these ones here, these bottom functions here, are what we refer to as the reciprocal functions. Okay, so if cosecant, which the abbreviation for cosecant is CSC, please don't say CSC, just like we don't want to say sin for the sine function, it's sine. We don't want to say CSC, we want to say cosecant. So say it that way in your head so you get familiar with the vocabulary. Okay, secant. The secant of theta is the reciprocal of cosine, so it's equal to 1 over cosine theta. So since cosine theta is adjacent over hypotenuse, secant is hypotenuse over adjacent. Okay. And tangent, then cotangent, would be the reciprocal of tangent. That one's easy to remember, tangent, cotangent. So it would be the reciprocal of tangent. Since tangent's opposite over adjacent, cotangent would be adjacent over opposite. Okay, it's important to note that these reciprocal functions do not have a button in your calculator. Okay, so there is no button on your calculator, no calculator button for those bottom three. To get those, to type those into your calculator, you have to take 1 over tangent, 1 over cosecant, and to help 1 over cosine. And to help you remember them, I always think that C's go with S's. So since this is sine, the reciprocal is the one that starts with C. Sine, cosine. Sine cosecant. And cosine goes with secant. C's go with S's. Okay, to help us remember those. Okay, all right, so now a little refresher on creating those trig functions. Okay, here, example 1. So we want to evaluate the six trig functions of angle theta. So the angle that they give us is this angle here. This is my angle theta. So I'm going to label my sides in terms of angle theta. So here's my hypotenuse, which we don't know the length of that side. So we are going to have to find it. Okay, but then this side over here, this side, the 12 is opposite. So this would be the opposite side. The 5 is the adjacent, and we don't know the hypotenuse. Okay, so this is a little geometry refresher. Okay, so geometry, if you didn't know one of the sides of a right triangle, we would use something called the Pythagorean theorem. Again, this is a lot of geometry review. The Pythagorean theorem, which tells me that the square of the legs, a squared plus b squared, is equal to c squared, where A and B here are the legs. So these two are the legs, and the C is the hypotenuse. So we can actually use that to help us find the hypotenuse in this case. So it really doesn't matter which one's your A and which one's your B. So we'd go 5 squared plus 12 squared equals hypotenuse, which we don't know. We'll go ahead and leave that at c squared. Okay, well, 5 squared plus 12 squared, 25, plus 144 equals c squared. So 25 plus 144 is 169. So c squared is equal to 169. So c would be equal to plus or minus the square root of 169. But since my c is representing a side length, it can't really be negative. We can't really have a negative side length, so we drop the negative. The square root of 169 is 13. So I know the hypotenuse is 13. So now that I know the hypotenuse, I can do our 6 trig functions. So again, I always start with SOHCAHTOA. Okay, so for I would do the sine. The sine of theta is equal to opposite over hypotenuse. So we would go, there's my theta, opposite is 12, hypotenuse is 13, so the sine of theta is equal to 12 over 13. So if the sine of theta is 12 over 13, the cosecant of theta would be the reciprocal, 13 over 12. Okay, we repeat that now for cosine. So the cosine of theta would be adjacent. So here's my theta. Here's my theta. So now I do adjacent over hypotenuse, which is 5 over 13. So since cosine of theta is 5 over 13, secant of theta would be 13 over 5, just the reciprocal. And then last we have tangent of theta is opposite over adjacent. Opposite is 12. Adjacent is 5. So then the cotangent of theta is the reciprocal, which would be 5 over 12. So there we've created the ratios. Okay. All right. Okay, move on. Okay. So now we have in a right triangle, theta is an acute angle, and sine of theta is 4 over 7. Evaluate the other 5 trig functions. So we have a right triangle, and we have some angle theta. Okay, so this one over here again would be opposite, because it's across from my theta. This one here would be adjacent, and this one here would be my hypotenuse. Well, we know that the sine of theta, if we use SOHCAHTOA, we know that the sine of theta is equal to opposite over hypotenuse. So that tells me that my opposite is 4. So that 4, so this 4 is my opposite. Okay, so that 4 there is my opposite. And the 7 then must be my hypotenuse. Okay. So now we need to find the adjacent side. So again, we're going to use our Pythagorean theorem. A squared plus b squared equals c squared. Again, the c is always the hypotenuse. So a squared, it doesn't matter which one we use. Let's go ahead and let's have our a be the adjacent side. Obviously a. A squared plus 4 squared equals 7 squared. So we'd have a squared plus 16 equals 49. Okay. So we would subtract the 16 to the other side. So a squared equals 33. Square root both sides. A is equal to the square root of 33. We would simplify that if we could. Square root of 33 is not a perfect square. We would simplify the square root of 33 if there were any perfect squares in it. 33 is only 3 and 11, neither of which are perfect squares. So we'll leave a as the square root of 33. Please leave it exact when you can. So now, since we know sine, now we can find all of the rest of them. We want the other 5 trig functions. Well, we know that the sine of theta is 4 over 7, excuse me. So then we know cosecant is the reciprocal, 7 over 4. So now cosine of theta would equal adjacent over hypotenuse, which is root 33, over hypotenuse is 7. So then that means secant of theta would be 7 over root 33. If you remember from earlier, we do not like square roots in our denominator, so I'd have to multiply top and bottom by root 33. So secant of theta would be 7 root 33 over 33. So there's the secant. And then now we have tangent, cotangent. So I'm putting them down here because I'm out of room. The tangent of theta, opposite over adjacent. So 4 over root 33. So again, we would need to rationalize that denominator. So we'd have 4 root 33 over 33. So there's tangent. Now we need cotangent. I'm going to take the reciprocal of the original, this 4 over root 33, and we get root 33 over 4. So there are our other 5 trig functions. We found cosecant, we found secant right here, secant theta is right there, tangent theta is this guy right there, and cotangent's right there. Oh, cosine, don't forget him. Okay, our other 5 trig functions. Right, next. Okay, Trigonometric values for special angles. Okay, there are two special types of right triangles. If you remember from back in, way back when in geometry, we had a 30, 60, 90, which 30, 60, and a 90. And then we had a 45, 45, 90. Okay. And we actually had relationships for how these sides relate to each other. In a 30, 60, 90, we had a short leg. Of course, we always have the hypotenuse. And we had the long leg. Okay, so how they related to each other is the hypotenuse was always twice the short. So we're going to start with the easiest short. Okay, if the short leg's 1, then the hypotenuse would be 2. Okay, and then the long leg is this long leg is the square root of 3 times the short. So we take 1 times root 3, so that would give us just root 3. Okay, so we can use, and that's true of any 30, 60, 90. So we can actually use that to find the exact trig functions of our 30, 45, and 60. For example, I could find the exact sine of 30 degrees. The exact sine of 30 degrees, so we're looking at this angle right here, would be opposite over hypotenuse. So the exact sine of 30 degrees is 1/2. The exact cosine of 30 degrees, well, if we're looking at, if we're looking at this 30 degree, it would be adjacent, which is root 3, over hypotenuse, which is 2, root 3 over 2, and so forth. So we can find, and we could do the same for my 60 degree angle up here. Okay, so then actually the sine of 60 degrees would be opposite over hypotenuse, root 3 over 2, so forth and so on, So we can find the exact sine, cosine, tangent, all 6 trig functions of either a 30 or a 60 degree angle. We can also do the same for a 45. If you remember in a 45, 45, 90, both legs are the same. So let's make them both 1. Easiest number is make them 1. And the hypotenuse is equal to the square root of 2 times that. So then again, I could find, let's say, the cosine of 45 degrees. The cosine of 45 degrees, again, 45 degrees, cosine is adjacent over hypotenuse, so it would be 1 over root 2. We don't like it written that way, so we would do this, rationalize it, root 2 over 2. So the cosine of 45 degrees is root 2 over 2. Your calculator will give you an approximately for that, but we can find the exact using this information here. Okay, so you will need to be able to find the exact trig values of our 30s, our 60s, and our 45s. Okay. All right, we can use that then to find a missing piece in our 30, 60, 90s. So here we are given, this is a 30, 60, 90 triangle because it has a 30 degree side right here, 30 degree angle, excuse me. So this one over here would be our 60. Okay, and and we know the hypotenuse. Right, here's our hypotenuse. But we're trying to find the adjacent. So that tells me that we're going to be using cosine, adjacent hypotenuse. So we know the cosine of 30 degrees is equal to adjacent over hypotenuse, which is 8. But we know from this previous page, in a 30 degree angle, the cosine of 30 degrees right here is equal to root 3 over 2. So I can replace this cosine of 30 degrees because we know the cosine of 30 is equal to root 3 over 2. So I can replace the cosine of 30 degrees with root 3 over 2 equals x over 8. And then now I'm going to means extreme it. Remember, we multiplied the root 3 times the 8. So we'd get 8 times root 3 equals the 2 times the x, so 2x. We would divide both sides by 2. So x would be exactly equal to, I can simplify this 8 over 2. 2 goes into 8 4 times. 4 root 3. So I found the exact value of that adjacent side. Using my calculator, I would just find the approximately. Okay, so we're going to do that in the next problem. We'll use our calculator to find the approximately. All right. So Here, example 4. This is not a 30, 60, 90 triangle. If you notice, this angle here is a 28 degree. So we can't use our 30, 60, 90 or 45, 45, 90. So we're going to have to rely on the trig values in our calculator to find both side A and side C. And we want to solve the entire triangle, which means we want to find everything. So we also need to find angle B. So it doesn't really matter where you start. I think angle B might be the easiest place to start because I know that these two angles, angle A here and angle B, have to add up to 90 because all three angles add up to 180. This one's already 90, so these two have to be 90. So to find angle B, I take the 90, subtract the 28. So the measure of angle B is going to be equal to 62 degrees. Okay, so we found the measure of angle B. Now we need to find side A and side C. We can't use the Pythagorean theorem in this problem because we don't know two sides. So we're going to have to rely on our trig functions. I think I'm going to find if this is my 28, this side's my adjacent, this side's my opposite. So I think I'm going to use tangent to find side A. So the tangent of 28 degrees would be equal to the opposite side, which would be A, over the adjacent, which is 15. So now I'd multiply both sides by the 15. So then A is going to be equal to 15 times the tangent of 28. So now I can get an approximately for this, 15 the tangent of 28. So I would type in my calculator 15 times tangent 28. Okay, double checking, word of caution here. Word of caution, check your mode. Check the mode on your calculator. Mode is right next to the second button. You need to make sure that you're in degree mode because this angle is in degrees. So you want to make sure that you're in degree mode. There's a radian mode. We'll talk about that in the next section. Okay. So we would type in 15, the tangent of 28. We get approximately 7.98. Okay. So that gets me my opposite side. Okay, and now we could either use the Pythagorean theorem or another one of our trig ratios. I think I'm going to try using cosine to find angle C because we know adjacent, trying to find hypotenuse. So the cosine of 28 equals adjacent 15 over hypotenuse C. So now what do you do when the C's in the denominator? The C's in the denominator there. Okay, I'm going to turn this cosine into a fraction so I can means extremes it. I'll take the cosine of 28 times C. So that would give me C times the cosine of 28 equals, then multiply the 1 times the 15. Okay, so now to get this C over here by itself, I'd have to undo a multiply. So I'd have to divide both sides by the cosine of 28. Those divide to 1. And so C is going to be equal to 15 divided by the cosine of 28. So if I use my calculator to approximate that, I would end up with approximately 16.99-ish. So I found my other two sides approximately. So if you have a 30, 60, 90, you need to find it exactly using our 30, 60, 90 relationships. Okay. If it's not a 30, 60, 90, like here in example 4, we can use our trig button on our calculator, our sine, cosine, tangent button to find them. Okay. Next, last example. We're skipping example 5. Okay. Example 6. A parasailer is attached to a boat. A parasailer is basically the people who hold onto a really large kite and fly up in the wind. A parasailer is attached to a boat with a rope 72 feet long. So I'm going to go ahead and I'm going to draw down here. I'm going to draw my water. So I've got my water here. Okay, and I've got my parasailer. So my parasailer is up here on its kite. So we'll call this up here point P for my parasailer. And then down here I've got my boat. Here's my boat. Okay, so it's attached to that boat with the rope. So let's go ahead and let's connect it there with a rope. So there's my rope. There's my rope. And my rope there is 72 feet long. Okay, the angle of elevation. Okay, what the heck does that mean? The angle of elevation. Elevation is the angle looking up. Angle of elevation is the angle looking up. It's always measured from the horizontal. Meaning it's always measured from the left and the right. Okay. There's another type of angle. It's not an angle of elevation. It's called the angle of depression. And just like when you're depressed or feeling down, it's the angle looking down. But again, it's also always measured from the horizontal. Okay, so you might have to draw a horizontal in. But we kind of have our horizontal already, and that's the water here. This is our horizontal. The angle of elevation from the boat to the parasailer. So here's my horizontal right here. So it's the angle from the horizontal looking up. So it would be this angle. My angle of elevation would be this angle right there. Is 28 degrees. So if I go ahead and draw in a few extra lines, if I create that up and down, I can create a right triangle here. So we want to estimate the parasailer's height above the boat. So we're looking for how far up in the air is it? So we're looking for this height right here, that H. Okay. So we know the angle. We know this is the rope is actually the hypotenuse in this case. We're trying to find the opposite side. So if we're trying to find the opposite and we know the hypotenuse, that would be sine. The sine of 28 would be equal to the opposite, which is h, over hypotenuse of 72. Multiply both sides by the 72. Since this isn't a 30, 60, 90, an approximation is okay. Or 45, 45, 90. So h would be approximately, type in 72 times the sine of 28, we get approximately 33.8. My units in this case is in feet. Our rope is feet long, so it is 33.8 feet above the ground. Okay. All right. Good luck on your practice. Come see me if you have any questions.